Okay, so now we're getting to the last part of the experiment, and we really only need to take one reading with this, but we are going to set up a couple of things and work with some equipment that we're familiar with and introduce something new. So let's look at what we have. We'll clear off what we don't need. So you're asked to calculate the time constant and set the square wave period to 10 RC. So the approximate value for that was 0.01 seconds. So that frequency corresponds to 100 hertz. And if you see here, we have the function generator that we used the last time we had the capacitors out. You set F, and so F is frequency, and so you enter in 100, and then you enter in the hertz. So you got a frequency of 100 hertz. Right now we're setting it to 2.0 volts amplitude. The amplitude we can adjust to fit our needs. So we have the frequency generator set to the, so it's going into the resistor. So again, the same 43,000 ohms we had before. And coming out of the resistor, it's then going into the smaller capacitor. So don't forget the measurement of the smaller capacitance, and then going back out. So it's alternating charge, discharge, charge, discharge. And that's where this instrument comes in. This is an oscilloscope. It's a toy version of the big professional caliber oscilloscopes we get in the lab, but it'll do for this experiment. So an oscilloscope is a voltmeter, basically. So we are going to measure the voltage across the capacitor using the oscilloscope. So what we're going to do is turn it on and give it a couple of seconds to boot up. And so let's look at what we're seeing. So we're already seeing a bit of the square wave. So we've got it set to 0.5 milliseconds per division. We can adjust that, and 0.2 is too small. But we can do 1 millisecond, and you can see how much of a you can see that you get the charge, which is when it's building up like this, and then you get the discharge when it's going down like that. And we want to get it to fill the screen. So we're at 0.5 volts per division. So a division is the full square. So we're not so much interested in the amplitude, but we want to be able to see things as clearly as possible. So let's bring the function generator over. Let's adjust this manually, or using this. All right, so let's hit the amplitude button. So we're adjusting this. So as we adjust, notice we're going, and we want to get all the way down. And the reason we want to cover the screen. And the reason we want to do that is that will get us as precise a reading as possible. So you see it's getting a little wobbly. But we can adjust that. If we hit OK, it'll pause for us. So what we want to do is find the time it takes to get halfway charged. So let's go to seconds per division. Or halfway discharged. Either way will work. So we want to find the length of time it takes to get from the top to about the halfway point. And so that comes out to be about, if you look at this, so cross is right at 0. Let's see. if I can adjust this some. All right. So maybe if we do half charge. So this is with 1 millisecond. So you see you're starting at the bottom. And so you might need a little bit of help here. That bottom corresponds to about 0.2, or rather 0.4 divisions. And then you go the 0.6 and then 1, 2, 3, 4, 5, 6, 7. So 7.6 divisions. So you want the time it takes to get 3.8 divisions up. So let's see if I can. All right, well, we're dropping 3.8 divisions from the top, from the bottom, or rather from the top, rather. And the location is in just the wrong place. Let's see if I can adjust that. It's 0.5 seconds, and all right. Okay. All right. We're going 3.8 divisions, and we want to see how far down horizontally it takes to get those 3.8 divisions. So maybe we want something less than, we'll try 0.2 milliseconds per division, see how that goes. And so we start right up here. So right at the beginning of the 4th division. And so 1, 2, 3, so it's about 3.8 divisions right at, so that's 1, 2, 3 divisions across. So that's 0.6 milliseconds. So that's telling you that it takes 0.6 milliseconds to discharge by half. And so it's a little bit, I mean, if you had the big oscilloscope, it'd be much easier to figure this out. Because you could adjust the position of the lines on the graph, and that would make it easier to read. But you're starting up here, and you're dropping 3.8 divisions, because we figured out that it was 7.6 divisions between full charge and full discharge. So 3.8 is about half. And so you see it crosses 3.8 fairly precisely after 3 divisions of time. And so each division of time is 0.2 milliseconds. So that's 0.6 milliseconds. So that's the half time you're going to use. And from that, you're going to calculate the time constant and compare it to the known value, which is basically 23 nanofarads times 43,000 ohms. So that's it for this experiment. And the next experiment is going to be on using figuring out how to measure different electrical quantities using some basic electrical equipment. But that's all for today. And as always, if you have any questions, don't hesitate to raise your hand and ask for help. But again, the half time for this was about 0.6 milliseconds.